Data is the center of gravity around which all applications revolve. In fact, Azure SQL DB processes over 30 trillion queries every day. Davide Mauri is here to talk about Azure SQL DB today on Azure Friday. Hello, friends. Today we get to talk about Azure SQL DB. And as a very special guest, we have Davide Mauri, who's a program manager for Azure SQL DB, to share with us some of the great things that are happening within the service. Welcome, Davide.
Yeah, thank you so much, Lara. It's a pleasure to be here, really.
Yep, and we go way back, so it's great to see you, even though we're remote. Davide actually used to work on my team, so it's fun.
Yes,
it's fun to see you again and hear more about what's happening in Azure SQL DB. So, what would you like to talk about to start?
Oh, yeah, so it's something that we already discussed in the past when we were working together. It's the importance of data and how data has a weight and a gravity, and therefore, it's becoming more and more important to push compute to data instead of, moving data around. For two reasons, I would say. The first one is that moving data around is super complex. Like, if you have, few megabytes of data, it's easy. But if you have terabytes of data, moving around is expensive, complex, and then you have consistency problem, integration. It's something you would like to avoid, right? And for the second reason is that, especially in the cloud, if you are paying for a database and you are not using all the feature it provides, well, you are leaving a lot of money on the table, right? So in Azure SQL, we have a huge amount of feature that not everyone knows because it evolved very quickly in the last years. So maybe you remember when we started, it was just, in quote, a regular database. But now I have a lot of stuff that not every developers know. And so I would like to start to share a little bit of these features that we crammed in the engine to make sure that everyone can use it at its fullest of potential.
That's great. That's great. And it is such a mature, rich service that we offer. And you're right, way back in the early cloud days, it was this cute little structure that you could put and get data. And the maturity and the capabilities are really there for developers to push that compute to the data,
right.
To do very complex computations. So what do you have to show us to start?
Yeah, so just to start, something simple, but I think that will start to open the mind of the developer and hopefully try to gain their curiosity so that they can start to dive into all the feature we have. Let's say that you have to create a dashboard and you want to have, some kind of charts on the top of the dashboard and some charts on the bottom to show how a project is performing. You are on time, how many people are working on the project, and so on and so forth. It always happens that you have to run several queries to aggregate data along several axes, like per project or per month. Of course, usually you go back and forth from a database and do this aggregation. But with Azure SQL, for example, you can do aggregation just using different aggregation using only one query. And this is not an incredible big deal, but it's a good starting point to see how much you can spare in terms of compute resource and task cost and simplify your architecture. And then we move into something more complex, which I love, that are the windowing function that allows to do quite a lot of complex calculation in the engine so that you don't have to move data on the, let's say, app service that you are running, do the number crunching there, and then moving back to the database. So let me go and show you some demo I prepared.
Great.
Okay, here we go. Let's start with the data. The first data is just to kind of glance at it. It's a timesheet, not very easy and common. First name, the project on this guy is working on, or is girl working on, the year, and how many hours he worked up to that day. And I decided to use a timesheet because it literally can be anything. It could be, of course, a timesheet, but also, let's say, the score in an online game, an IoT data coming from an IoT device. So it's very flexible to kind of relate to anything you're working on. And let's say that I want to create a dashboard where you have a project summary. So you want to see how many hours has been worked on each project. On the top, but on the bottom of your dashboard, you want to see also the kind of status per month. So you would normally execute two queries, one to aggregate data per project and another per month. But for example, using a very not so much well-known feature called grouping set, you could actually ask Azure SQL Database to execute two different aggregation reading the data only once, or even better, executing the query only once, which means that you don't have to execute the query twice. And as you can see here, I have that no matter which project someone is working on, in January, we have our team worked 1,900 hours, on February 2,100 hours, and so on and so forth. And then here, where you see the name of the project, but not the month, you can see the total for that specific project. So by just returning this data set to the application, I just avoided to execute two queries that could require, reading a lot of data, which means that I almost double my performance right now because, again, instead of executing it twice, I'm only executing once. And this is just the easiest option you can do. It's literally one simple command. But now let's do something even.
Just to interject, I mean, back in the olden days, you're right. I mean, we would have to write multiple queries. We would maybe put those to temp tables. We would join those.
Right.
And the complexity of that code was, and maintaining that complexity was much higher. So here, just using a simple grouping sets, we can collapse that to a single set of code, and that also simplifies and improves the performance because we're just doing one read against the data.
Correct.
Is that true?
Correct. And that's the key, right? Because every time we go from any application in cloud on premises to database, it's a round trip. And round trip means moving data. Moving data means paying money, literally today with the cloud, because everything is, something you can easily measure and understand what is the impact of its cost, right? So here, by basically avoiding to query the same table twice, we are just improving our performance a tiny bit. But imagine when you have something, with the cloud scale, used by millions of people, even a tiny bit becomes something, important. And that's just the tip of the iceberg. That's why I really want to make sure that developers know how many features are in modern relational post-relational database that they should start to look at and learn, because let me show you another thing that's very common. Typical matrix report. We all know, we all been there. A matrix report is like the bread and butter of all project managers and managers. So you know that at some point you would ask to have like, actually let me show you here a nice drawing I can make if I'm fast enough. Yes. So a typical project report is something like that, right? So you have your metrics. Here you have the cell. Here you have the cell with the details, right? But here you have the total of this column, and here you have the total of this row, and this you have the overall total, right? So on average, this means aggregating data once for the column, once for the row, and another one time for the overall total. At least 3 aggregation plus the aggregation to calculate exactly this value. So at least 4. So already from the 2 simple aggregation we said in the previous example, now we're already to 4, which this kind of report is so common that it's probably used, I don't know how many times per day by everyone who needs to look at how a project or a game or whatever is performing. So what we can do, for example, is group data across several different axes or logic. So by project and month, that will be, in our case, in our matrix, could be the intersection of project and month, so will be the cell. And then the project could be our column, and the month could be our row. And this is the total. So aggregating by not specifying anything mean group by all, right? So we can do something like that pretty easily. And here we go. We have, as before, the month and the project, and now month and project. So we can easily send back this result and have, any kind of modern JavaScript framework compose it into a matrix. But what I like about Azure SQL Database is that once you like something, usually you can compose it with other existing features. Like, for example, what we really need here would be to pivot this table so that we literally have the project on the row and the month on the column. And if we could generate this here, it will be even better, because then we just have to display that matrix on, I don't know, our React interface. That's exactly what we can do. So I'm executing my query, the one that I showed you before, with the 4 different grouping sets. I'm putting it into what is called a common table extension, which is nothing more than a way to separate this query from another query that is using it. So it's actually a subquery. And then I pivot my query across the month. So the result, I think it's quite impressive. It's exactly what you're asking for. All on Azure SQL, all using the CPU and the resources of the database, no data moved. I can then turn this, for example, in JSON. Maybe we can discuss this about in the next session, and send it back to my client, be it a web client or a backend, and it's done. It's super easy, really. And so that's why I really want to make sure that developers start to use all these amazing features. I don't know how many are using Pivot today, probably few, or the grouping set. But yeah, now they should start to use it, because if they have this need, this is already solved in how much? Like a minute? Amazing, right?
Right. And you're bringing less data back to the application.
Yes.
You're, like you said, leveraging the power of the data engine to do the calculation.
Right.
Lots of positives there. Great.
Yeah. So this is just, and I said this is just the tip of the iceberg, because here, honestly, we are just, unquote, doing a little bit more complex aggregation than the usual. But there are other things that I think we can explore, like, for example, windowing function. So let me talk about that. This is another amazing feature that I really, really love. So we always start from our timesheet data. And let's say that for some reason, I need to calculate an aggregation like we did before. But now I would like the aggregation to be on every row, because I need to compare, for example, how much hours has been worked by Zach against the total amount of hours worked by everyone in the project, to calculate the percentage, for example, right? How much time in percent he or she spent in the project. And I can use an aggregation function without using the group by. And this is a kind of interesting stuff, because usually it's a kind of a known thing that in order to use aggregate, you have to use the group by. Well, that's not true anymore, because you have the over clause that says calculate the sum over all the project that has the same name. So I'm calculating the sum not across everything, but across all the rows that belongs to the same project. Automagically, I would say, in the sense that you will see that Azure SQL Database can automatically understand that he has to group by all the alpha project, calculate the sum, stop it, start to get the next project, calculate the sum, and put it on my result set, and so on and so forth. So let me show you. This is pretty interesting. So here, for example, I can say that this first row now contains also the total of the project hours. So this is the total of all the hours reported and worked by anyone on the project alpha. If I move down where project Bravo starts, here we go, you will see that this is another value. Because of course, the aggregation says on per project. So without doing anything complex, without doing any, kind of imperative logic, I just declare that I want the data partitioned by project, and Azure SQL does all the complex stuff behind the scene for me. And I can also use not only the sum, but for example, the average to calculate on average how many hours each person spent on Alpha project or on the Bravo project. And as you can see, this can start to bring some ideas. Like, for example, I can maybe calculate a running total. Because here I am calculating the total of all my projects. But what if I would start to say, okay, let's calculate a running total instead of having immediately the result of all the sum. Yeah, I can do that too. Because the over supports by order by, which means that on per project, and in this case per project and per year. So I can even have more than one logic upon which split the values. I can have, here we go. So let's start with the running total here. We start to 28, then we add 45, and then we add 86, and so on and so forth. And as you can see, this is increasing, this running total. So I can even calculate a running total, which is again a very common requirement in reporting. So this is just to show that something that before was almost impossible to be done in Azure SQL or super complex, now can be easily done in Azure SQL. So again, I have a result set with everything I need, and I can do all the calculation where the data is, and my life is easier, right?
And these are not new functions. These are
right. This is quite, it's been a while, I would say, probably 10 years, probably more. But there are two important things about that. Not only they are not new, but again, you know, me and you, we started quite a long ago in the field, right? And so we had the luck, I would say, to see these things evolve. And I would say we evolved with them, right? Yeah. Exactly. Now, imagine someone that, you know, starts working today just fresh out of the university. How many things she has or he has to learn? Wow, it's amazing, right? So I think we need to help them to see, you know, to kind of have a kickstart and see exactly what can be important for them, what can be maybe a little bit more niche, so they can learn it in a second kind of round. That's important, I guess.
And it just goes to show that the maturity and the power of the T-SQL language that was introduced with SQL Server in the box it's available in the service, and it's available for developers to take advantage of the power of the compute in the service.
Absolutely. And the last thing I would like to show you regarding exactly what you just said is something that I guess every developer at some point struggle with. Like in the database, as you know very well, there is no inherent idea of ordering. Data is not ordered. But still, as human being, we like to think, you know, this is the first row, this is the second row, because sometimes it makes it easier for us to understand which algorithm we should implement to solve a problem, right? Now, for years, there was no support of having access to the previous row or the second row, unless using some obscure technique, let's say. But with the windowing function, specific function to support this need has been introduced. They are called, for example, lag, lead, or first value and last value. This is super common and easy today. So let me show you right away how they work. For example, let's say I'm focusing on this row, and I want to access the row that is previous, so it comes before this row, based on the reported on column. So first of all, in order to define previous and next, I have to define which is the column I want to use to order data, right? So here I'm ordering by reported on. So based on the order of the reported on, now I can say that these rows becomes before this one, right? Because 19 happens before 23. So I can ask when I'm this row here, the ID 816, maybe I need to access the previous row to understand how much time passed between the last time someone reported he was working on a project and now the time reporting that I finished to work on that project. So if this is my day when I report that I worked 86 hours on the project, who was and when was the last report done? Well, I can look at the previous data by using lag. With lag, I can access the previous row. With lead, I can access the next row. With first value, I can access the first row in my, it's called frame or window, because I'm partitioning by project. So the first row here, the first value would be the first row of the project alpha. So in this case, will always be this data here, right? So the project started on the 8th of September 2019. And last value, as you can imagine, is actually the last one. So when the project was last reported on or probably finished. So by using this little function that they do not aggregate data, but still they support the overclose, as a developer, now my life is much easier. No more join, no more complex, things to try to just access the previous row. Here, for example, calculating the lead time or the difference in time between the reported day and now, for example, from here to here, is super simple. I do a lag and then I calculate the difference, for example. Now, some developer ask, okay, nice, you are using the same column here, so maybe that's a requisite. No, with lag, lead, or first value, I can access anything of the previous row. So let's say, for example, I want to make a difference between the hours I reported and the reported hours of the person before me. I can just do that. Lag, hours worked. So what I will be doing right now is, here we go. So if I focus on this row, this is what I reported, this was the person before me reported, and this is what the next person will report. So it's super easy, and as you can imagine, again, I can do a lot of complex calculation here right now. I could, for example, calculate the moving average, I can calculate the growth ratio, again, without moving data out of the database, which is super important.
Yeah, that sounds great. And you're able to just execute functions and grab information for each of those partitions. So
yes,
each partition,
correct.
you're able to pull information to, again,
Right.
simplify that experience for me as a developer to write this code and manage this code. And
Absolutely.
yeah, that's great.
And
Right.
yeah, that's not the last thing. What I want to show you is something even more interesting. Now, let's say that you learned, all this stuff that we discussed. So now you are doing, aggregation like there is no tomorrow, running total, calculating percentage, calculating growth, calculating ranks, because also there are ways to generate raw numbers. And of course, you execute your query and, it works pretty well, right? So we don't really care about the result right now. What I want to show is that, of course, right now we are returning information with complex calculation for all projects. But of course, you probably are focusing on a specific project, right? So you want to filter a specific project. And after all this calculation, you decide that you want to add a filter saying I'm only interested in project alpha. What would normally happen if we don't do all this calculation on the database is that basically we take all these queries, we run them, we move the data to the client, and then the client has to remove the data that is not needed, which is a huge waste in terms of resources, in terms of power consumption, in terms of money, and we don't want to waste anything today, right? Luckily. So what Azure SQL can do is that it can understand that Project Alpha can be filtered way early in the query, like on the top. So when I do this, it's not that Azure SQL is reading everything and then removing the data that is not useful to return only the alpha. But if we take a look at something we can then show in other episode, the execution plan, we will go and see that here, you can see that here we have a seek predicate, which means that we are only reading the rows where the project is alpha. So Azure SQL is literally skipping all the rows for which the project is not alpha, so it's not reading it. For this reason, the query is fast, but it's also cheaper, which means you are using less CPU, less network, because you transfer less data. Basically, you are sparing money and having your application more efficient. So by pushing all the logic and all the calculation to the compute as an Azure SQL database, we can even optimize your query and make sure it's more efficient. And that's a unique thing, because if we have moved all the data to your application, then we are out of control and we can't do anything, right? So by pushing data, by pushing calculation to data, there are better chance that we can optimize the query, make it more performant, more efficient. So that's super important to understand, because there are literally hundreds and hundreds of engineers working on the optimizer. And so every developer should take advantage of all the work that these engineers are doing every day, right?
Good point.
So.
Good point.
Yeah, as a developer, I'm super lazy, and I want to take advantage of anything that the others have done for me, right? Because that's how I can focus on my job, which is, I don't know, maybe create a reporting solution, not like finding the best way to optimize the query. Yeah, it's part of my job, but if the engine can do it for me, I can focus on making a super nice, report, for example, which is the added value I can contribute, for example. Yeah, that's all I wanted to start to show.
Yeah, those are just like you mentioned. I mean, these are just a couple of examples of the
Right.
many powerful functions that are available in Azure SQL DB. Where can we go learn more about these functions and other SQL capabilities?
Yeah, there are plenty of stuff that you can find on the web. So I just want to give 3 hints. So the first one is, of course, the SQL documentation is full of details about how the engine works, what are the function tutorials. But if you want something more practical, specifically thought for developers, we have in the docs.microsoft.com, you can search for Azure SQL Database, and we have more than 30 examples end-to-end showing, like, for example, how you can create a full stack solution or, for example, using a serverless REST API. So literally everything end-to-end. And the last option, just a shameless plug, last year, along with other colleagues that I pretty sure you also know very well, we wrote a book specifically taught for developers who want to start to learn how to use Azure SQL in their daily job, but from a very practical perspective. So we also give hints and information about the theory, but it's more like I need to improve the performance of my query, which index I should use and why. And then we can also give hints on maybe understanding what is a B-tree, how it works if someone really wants, but very practical.
Oh, that's great. Thank you so much. A rich set of resources to help all of us learn how to take advantage of these and other great features of Azure SQL DB. We've been learning all about Azure SQL DB today on Azure Friday.
Hey, thanks for watching this episode of Azure Friday. Now I need you to like it, comment on it, tell your friends, retweet it. Watch more Azure Friday.